Welcome to IBL here at IPC Apex Expo. I'm joined by Dominic Vust, who's going to tell us a little bit more about this new inline vapor phase system. So welcome,
Hi.
Dominic.
Hi, nice to have you here.
Yeah, so I mean, the beauty about vapor phase systems is you get this homogeneous heat transfer across the board. You get a very even delta T.
Correct.
Normally they're shown, you see these as batch machines. Here we've got an inline. Where's the applications for an inline vapor phase?
Our main customers are more in the military and in the aircraft.
Okay, so high reliability, high volume
Correct.
customers.
But with this machine we try to go more in the automotive sector because we have reached a very high throughput with this machines with the HS and the CCS series.
Okay, so let's talk a little bit about the throughput. I mean, it can be a 2-lane or a single lane. What's the maximum board size you can do?
On this machine, the HS 1005, it's 1 meter to 500 millimeters.
Okay,
maximum.
so that's a fairly decent size. Yeah.
We also have a 1208, it's 1200 millimeters to 800 millimeters.
Right. Okay, well that's pretty big. That would be for LEDs and things like that?
Yes, of course, yeah. Like that.
Yeah, okay. So the type of gas that you're using for the vapor phase is Galden, the normal Galden material, but it's I guess pretty safe. It's in the environment down inside the machine. Can you explain how the system works?
We have one module in the front where we have a smart collect function, what we call. So you only tell the length and the width of your board, and it's automatically calculating how much boards you can get in the soldering area.
Okay.
So when the smart collect area is full of boards, so you can have multiple boards on one lane, then it's automatically transported to the soldering area.
So, just to get this right, you basically put in 2 or 3 boards in one go, so enough to fill the chamber, as it were. Then the chamber door opens, they all transfer through into the reflow chamber, as it were, and it closes behind them, and then you get the homogeneous gas transfer of heat. One thing you're doing differently here, as I understand it, is you're moving the bath containing the liquid or the gas liquid, and rather than moving the board down to meet the gas.
Correct. That's our new concept on this high throughput inline machines, that we don't move the board in the soldering area anymore. So we only put them in the soldering, and then it stays on the same position. So then we lift up the complete medium tank with the liquid, and we lift up the vapor blanket to the board. And we can also lower the vapor blanket again to create a soaking, for example. With this process, it's a very stable and homogeneous process.
Right. So why do you do it that way? You think it's a more stable process doing it that way than doing it the old way, where you put the board down to the gas?
Yes, because you can move very slow and very smooth with that medium tank, and can create the vapor blanket to the board.
Okay.
And also one main advantage is that we can use much higher weight in that process. With the other machines, we also were limited up to 14 kilograms because of the transport system. On these machines, we can easily go up to 25 kilograms because we don't lift it up anymore.
Right. Now, I notice at both ends of the machine you've got basically ducts that take out the gas, suck it out, and the heat exchangers that then change it back into liquid and recycle it, essentially.
Yes, that's very important on the vapor phase, that you have your vapor only in the soldering area. You don't want to have to come out because then you have a high consumption. So we need heat exchangers to get it back in the tank. And that's our main goal, to have the lowest consumption of the Galden.
Excellent, okay. So compared to other forms of soldering, I mean, I guess the Galden material itself is probably relatively expensive, but you're constantly recycling it. But the other benefit is you're not using nitrogen.
Correct. In the vapor we have an inert atmosphere already, so we have a very high quality of solder joint without using any nitrogen.
Yeah.
And we have, over the very good heat transfer of the vapor, we don't use so much electrical power. So the environment is very good.
Right. Good. So this machine itself actually was developed by the old R&D Vapour, which were based up here in the Midwest, but was acquired by IBL. Is that correct?
R&D Vapour is a daughter of IBL, and we did develop it together with R&D.
I see.
So IBL and R&D together.
I see.
And of this machine, we now have the IBL version. That's a CCS. That's even a faster one again. But based on the same soldering principle.
Okay, excellent. So what is this model called then? What do you call it?
It's the HS 1005.
HS 1005 inline vapor phase.
Yes, reflow of it.
Dominic, well, thank you very much for showing it to us today.
Thank you. It was a pleasure to have you here.